Jordan, you're in the video. Be serious.
Huh?
What?
What?
Huh?
In the video, be serious.
Yeah, you're in the video. Be serious.
What's up, video? My name's Jordan. This is Jay. There's Katie.
That went out the window. Okay, so up here, I'm going to work on this one problem that's in black first. It says in the combustion reaction of C8H18, which is just some fatty acid, and a collection of 7.85 kilograms of carbon dioxide, how much C8H18 did you start with? So we're trying to work backwards. First key to this is you have to get a correctly balanced chemical equation. So start with what you've been given. C8H18. It's a combustion reaction. So I know a combustion reaction is literally hydrocarbon. Voila! So hydrocarbon. Plus oxygen, which oxygen by itself is diatomic, so it's O2. Will always produce carbon dioxide and water. Now in this, we're not balanced. So we have to balance them. So this is what we would do. I write down my elements.
With teacher permission only, let me repeat that, with teacher permission only, we are now ready for freshmen, juniors, and afternoon trade school students to report to the auditorium for the band concert. With teacher permission only.
You may go if you want to go. I am recording these. I will upload these tonight. Your quiz is still tomorrow.
I'm broke, right?
Alright, so in this, we're going to label it out. I got 8 carbon, 18 hydrogen, and 2 oxygen on my reactant side. Hopefully you can get that. If not, God rest your grave. Right side, I got 1 carbon, 2 hydrogens, and 3 oxygens. It's easy as 1, 2, 3. Now in this, we got to start balancing. Like I've said before, whenever you're dealing with these balancing, we always want to start with everything else except for hydrogen and oxygen. We always save for last, mainly because oxygen is normally left by itself like this. So let's look. I got 8 carbons on the left, 1 carbon on the right. I got to fix that. So how can I get 8 carbons? Find the carbon. There's a 1. Means if I do 8, it'd be 8 times 1, which would give me 8 carbons. But since I stuck the 8 in front of carbon dioxide, it also changed my oxygens. So I now have 8 times 2, which is 16, plus 1 oxygen, which is 17. Alright, everything else is balanced except for hydrogen and oxygen, so let's now balance the hydrogens. I have 18 hydrogens on the left and 2 hydrogens on the right. How can I get 18 hydrogens on the right? Put a 9. 9 times 2 is 18, gives me 18 hydrogens, but oxygen's in water, so now we've changed the oxygens again. Here is 8 times 2, which is 16, plus 1 times 9, 9, so 16 plus 9 is 25. Not 26. A couple of people made that mistake. Make sure you can do your math properly. Now this is the way that I do it. I look at the number I'm given for oxygen on the right, so 25. Take 25.
I'll be back. I gotta go to Painter's. I need these crates. I'll write it down there. Can you send me Kool-Aid?
Did I not give you others? Did I not give you these?
Yeah, we just missed you.
I got you. Hey, when do you need them? Can you give them to you third?
I'm trying to fix transcripts right now,
Okay.
so if you don't care to.
Yeah, I'll do it right there.
I'll stop on the way back up.
gonna take a short intermission.
Donnie, we need you in the freshman hallway. Donnie, you're needed in the freshman hallway.
Anybody else dying to get the new intercom system installed?
I thought you were gonna say anybody else dying. I was gonna say the same.
Oh, my ankle feels like I'm dying, but I'm okay. I don't want to tell you. It's more embarrassing than it is anything.
Did you fuss?
No.
They can't be that embarrassing. You didn't fall.
Did you like twist it?
Practically, we were playing a game of, I don't know what you call it, badminton or whatever.
Yeah, badminton.
With birdies.
Yeah.
Yeah, well, somebody had like hit one, so I like was running, and I stuck out like this to pull this like awesome move, and I hit the birdie, but whenever I did it, my left foot stuck, and when it stuck in this old horseshoe pit,
Oh, no.
and it had mud in it, so we went and slid forward, and I crilled my ankle, and then, being the man that I am, I didn't stop there. That's right, ladies and gentlemen, I went farther. I went wade fishing yesterday, which is totally worth it. Caught a beautiful, beautiful, almost 3-pound smallmouth. It's a beautiful bass. Yeah, sure, give me a second here.
Did you put it back in the ocean?
Oh, yeah, yeah.
Well, I put it back in the river.
Did you put it back in the ocean?
Wow, that's shocking. Being very generous.
Look at my grades. Wow, that's shocking. Whoa.
So, is this practically what the quiz is going to be about?
Pretty much.
The following students will be report to the office. Samantha Bailey, Savannah Sowers, Madison Blankenship, Alyssa Yoder, David Klein, Maisie Hefty.
Would you count that by two too?
But now it's like you drop it.
This
This is what you get.
Are you good?
I ended up getting, like, I had 25 over here and 2 over here. First,
It was like,
and then, like,
it
when I
was
tried
like
to, like,
four,
balance it,
like-
I get 12.5. But since I got a decimal, I just times everything by 2. And then they all evened out.
I love you.
So if you get a
These are the
decimal,
best thing that ever
when you're
happened.
half, then times everything by 2, so you get whole numbers, and they're all balanced. Yeah, I was like that. I was like, every time.
And then after that, where would you start?
Like, after you balance them, you start with your things, and you go to grams, which you go to.
I know, it's so aggravating. I feel so
You
good.
go to grams and you put it in your equation, whatever one, and you convert it to moles. You get moles. And after you do the moles, you do your mole thing.
So we're going from grams to molecules.
To moles, not molecules, moles. Nothing with molecules in this.
That's why I'm so
Yeah.
like, this doesn't say moles or anything. It just says.
When it says how much did you start with, he's meaning asking for grams. So you have to go from
Like to that and then
You have to go
back.
from grams of carbon dioxide back to grams of whatever the heck this is. So you start with
To moles of that.
you go to moles of that, and then you do the mole ratio thing, which you get the 2, which is from 2, 6, 8, and then put whatever you're canceling out on the bottom. Or put, per se, put whatever you're wanting to get on the bottom. Put whatever you're
I know that,
but I just don't know why.
What?
I'm trying to get to that.
Miss Katie says we.
Because it's asking for C8 plus moles.
That's nice.
This thing, it's asking for that if you're in carbon dioxide.
Yeah, I think I like this Katie better anyway.
And you have to go to
You don't talk.
Okay.
Yeah.
So after you do the mole ratio, you get your answer, which is like this, and you get mole CAH18 number 1, and then you convert this into grams, and you get that.
You know, I needed that laugh. I really did. I really did.
I did it a little bit.
The second one. Oh. What'd you get for the bottom?
Balancing.
Emmanuel Mosley, come to the office. Emmanuel Mosley.
Okay, sorry about that.
Don't second guess yourself.
Did you get 16?
All right.
Yep.
Anyway, now back to the board. So here we are. This is what I'll do here on the right side. I'll take the number of oxygens I have, so 25, and I will divide it by 2. Why? Because I have 2 oxygens here. Once you do this, 25 divided by 2 gives you 12.5. So we'll put 12.5. Now this is a problem, okay? You'll get some professors in college, especially the upper level chemistries you take, could care less about that half there. As for everyone else, they care. Like I'm pretty sure on the SAT, if they ever ask you, the ACT, sorry, not SAT, ACT, to balance something, you don't want to leave that half there. Okay? You want to fill that in. So now, what can I multiply all these coefficients by to get rid of that 0.5?
2.
2. The reason I can do that is 0.5 is equal to 1/2. So if I take 1/2 and times it by 2, is really times it by 2 over 1, which will be equal to 2 over 2, which is equal to 1.
This is like complex thinking.
So in this case, I'm multiplying everything by 2. So what number is here in front of this?
1.
1. 1 times 2 is?
2.
2. Everything has to be multiplied by 2. In this case, 12.5 times 2. 25. 8 times 2. Realize we multiplied the left side by 2, we're multiplying the right side by 2. What's going to go here in front of the water?
18.
Very nice. And now we're balanced.
Do you have to change all the stuff on the bottom?
Where?
Like the 8 and the 18 and the 25?
I mean, you can if you want to check and make sure
But
it's
it-
good practice, but it's balanced.
Okay.
I just didn't check it. That does change everything though. So if you're like nervous about it and you want to check it, go right ahead. So now here's the thing. You have to choose your starting point and your end point, where you're going, to make sense of what we're trying to do here. So in this case, we're starting with carbon dioxide. I gave you 7.85 kilograms of carbon dioxide. So I'm starting here. How much how much CaH18 did you start with? I'm trying to go from here to here. And I'm trying to find this in grams. So the whole key to this is starting point, end point. How we're going to get there. Okay? I'm starting in grams here. To get from here to there, I have to get to moles.
Why do you have to go to moles before you can go to that?
Because remember what moles is. Moles is that thing, it was kind of like 1 mole is equal to 6.022 times 10 to the 23rd molecules, compounds, atoms, formulas. It didn't matter. It was the same thing. If I looked at you and I told you I had 1 mole of hydrogen, then I had 6.022 times 10 to the 23rd atoms of hydrogen. If I tell you I have 1 mole of water, then I have 16.022 times 10 to the 23rd molecules of water. This is a way to shorten the count. This, when you're looking at mass, the mass of water is greater than the mass of hydrogen. You look at giving me, I don't feel like I'm helping.
I just don't know why we're going to grams, then moles, then back to grams.
Because you have to use, like, there has to be a common factor. Okay, the mass of this, it weighs more than this. With this, there we go. You can't just go from, oh, I'm in grams of this, so if I just went to grams of that, you have to get to moles first because moles is a count.
So we'll always go to moles.
Always. You'll
these.
always, in
You'll go-
everything.
Okay.
In your upper level chemistry class that you'll take in college, when you're trying to figure out, okay, when you're sitting inside of a lab class and they look at you and they give you some reaction, they're telling you how much of this do you have to start with to produce this much. You cannot go from mass to mass. You have to go from mass to moles to moles to mass. You have to use moles because moles is like a count. That's all it is. Instead of it being if I gave you a 5-pound bowling ball and I gave you 5 pounds of feathers, they both weigh the same, right? How many bowling balls did I give you? 1? Right? I gave you a 5-pound bowling ball. How many feathers did I give you?
Probably a lot.
A whole bunch, right? But they're both 5 pounds. But over here it's 1. Over here it's a whole bunch. Let's say there's 1 million feathers. Okay? The moles are the count of those. That's where you can use the mole ratio to work between. So you gotta go from grams to moles of carbon dioxide to moles of C8H18, and then you can get to grams of C8H18. This is how you want to do it. Short on time, so I want to jump some steps here. I literally got 4 minutes. So in this, we're going to start out with what we're given. You cannot use kilograms. Why? Because your conversion factors are not in kilograms, they're in grams. So you have 7.85. So 7.85 times 10 to the third grams of CO2. Set it over 1. Now we're going to set up a conversion factor. I want to get into moles of carbon dioxide. So to do that, I need to use the molecular mass. I want moles of carbon dioxide, so moles will go on top. On the bottom, I'm trying to get the grams of carbon dioxide to cancel. So grams of carbon dioxide end up on the bottom. And the number that goes with it is 44.01. If I'm wrong, somebody correct me.
It's right.
Thank you. Okay, so grams of carbon dioxide have canceled. It leaves me with moles of carbon dioxide. Now, I can get from moles of carbon dioxide to moles of C8H18. And to do that, I use the mole ratio. So I want to be left with moles of C8H18. So moles C8H18. But I need the moles of carbon dioxide to cancel, so it goes on the bottom. So moles of C8H18, what number is in front of the C8H18? 2. What number is in front of moles of carbon dioxide? 16. Okay, now I'm in moles of C8H18. Just as a side note, yes, you can simplify this to 1/8. If you're nervous about that and you're like, what did he just say? Leave it as 2 over 16.
Will it change anything or make it faster or easier? if you
Makes it
change
faster.
To 1/18.
Yeah, it makes it faster because then you don't got to worry about multiplying by 2.
Okay.
Now, I'm trying to get into grams of C8H18. So grams of C8H18. So I got to get moles. Cancel out. So C8H18. What number goes on top? 114.46. 26 grams of C8H18. Where did that number come from? That is the molecular mass of C8H18. I pray I don't need to stress that too much. All that is just, I'm looking and I'm going, carbon, hydrogen.
Carbon's mass times 8, and then
8.
nitrogen's mass times 18.
Yep, that's all it is.
Okay.
And then add them together. Yeah. Then you punch all that in the calculator. And for
2,547.5488.
grams of CaH18. The only thing I can stress to you here is with this, just make sure that you're following this, okay? So like, you're gonna punch in 7.85 e to the third, and it's divided by 44.01. Then it's times 2. Then it's divided by 16. Then it's times 114.26.
So you times and divide?
Yeah, because you have numbers on the bottom as well as the top.
But if you simplified it, you wouldn't times it and you would divide it by 8.
Yeah, if you simplify this out, you have 1 over 8. So
Okay.
7.85 e to the third divided by 44.01 divided by 8 times 114.26.
Okay, so are you always gonna go from like grams to moles to grams? Or no?
In this class, yes. If I had more time, then no.
Okay. So we won't,
Now time
we'll
before
have
the
one.
third period.
So all of ours will be like that.
Yes, in this class, but whenever you get to college, they can take you all over. Remember all those mole conversions we did?
Yeah.
We went from molecules to grams, from grams to liters, from liters to molecules, from liters to grams. They can have you do all of that. Everything that is based on the mole can be done with this. Because this right here is like the background. Like scientists still to this day, if they look at a reaction and they say, I need so much of blah, blah, blah. And here's the reaction, here's what they're starting with, and here's how they're gonna make it. They literally calculate how much of that they need. Like in my analytical chemistry class in college, if our professor said we had to end up with this much of the product, we sat down with paper and pencil first, started with it, calculated it backwards, like we just did here. So she said that we needed 7.85 times 10 to the third grams of carbon dioxide. We did this calculation right here and calculated that we were going to have to start with 2,547.5488 grams of CaH18.
Mr. Hall, will you be here first period tomorrow?